It's David Spears, civil engineering instructor at Texas Tech University. Talking about internal forces and how we can determine those, and also reactions. This is solving for reactions. I have a strange beam here fixed at both ends, A and D, with a hinge at points B and C. The loads are as shown and the dimensions are as shown. First part of the problem is to draw the free body diagrams of each section as a means of solving for the reactions. So I've broken it up into three parts: the part between the hinges and the cantilevers at each end. I've drawn the reactions on a simply supported hinged beam. All I'll just have is a vertical reaction, and then on the cantilevers I have a moment at each end, plus vertical and horizontal reactions possibly. So the first one I want to work for is the middle part, and it's pretty easy. I don't even need to write an equation. You can, but I'm just going to look at it by inspection. I have 2 kips per foot, 16-foot span, symmetric, so half my load has to go to each end. So 2 times 16 is 32 kips total, and so I'd have 32 total in the middle. I'm going to get By is equal to 16, Cy is equal to 16. Now I have to take those forces and put them on the cantilever free body diagrams. So By is 16, Cy is 16. It's up on the middle section, so it's down on the cantilevers, equal and opposite forces. Good buddy Sir Isaac Newton. So I want to know, what's the horizontal reaction? Well, there's nothing to put a horizontal force in there, so Ax is equal to 0. Dx is equal to 0. Some of the forces in the y direction is easy. I've got Ay up and 3 and 16 down on the cantilever, so Ay has got to be equal to 3 plus 16, or 19 kips. Let's solve for the moment about point A at the support, at the fixed support. I can just see this moment is going to oppose, this is a support moment, it's going to oppose the 2 concentrated loads, the moment created by them. So I have 3, and it's in the opposite direction. I've shown it as counterclockwise. These are both going to cause clockwise moment, so it's just going to be equal to the numerical sum of those. 3 times the 6-foot moment arm plus 16 times the 10-foot moment arm. So that's equal to 18 plus 160 is equal to 178 foot kips. Pretty easy stuff. At the other end, cantilever at D, I've already solved for dx, 0. Sum of forces in the y direction, the only thing I have is my reaction dy plus the 2 opposing external forces, 16 and 6, so it's 16 plus 6 is 22 kips. Finally, I have the moment, the support moment caused by that fixed end. That's just equal to its opposite. I've assumed it clockwise at that end, resisting counterclockwise moment caused by both of the 2 concentrated loads. So I have 16 times 10 plus 6 times 6 is equal to 160, plus 36 is equal to 196 foot kips.